conference will now be recorded.
Today we're going to do a lesson on reflections and translations. So we're, if you look in your notes, it's two lessons together. So you're going to jump them together because both of them are pretty simple. All right. All right. The big thing to keep in mind. I don't know if I want to talk. I'll talk about these separately. I'm going to talk about these first. All right. So we're going to reflect. When you reflect something, you have to figure out what you're reflecting it over. Yeah. So there has to be a line of reflection somewhere. All right. And if I was to reflect a shape, this is the way you do it. You're going to figure out the perpendicular distance, right? Whoa, that is not the pen I thought I was using. All right. Find this distance, right? And that same distance gets reflected here. So if J was there, we're going to do this. That's going to be called, see that little apostrophe there? That's called J prime. You can have J double prime, whatever. But when you see that, when you see like A and A prime, A was the old shape, A prime was the new shape. Yeah? Not sure if I've shown you that before. So J prime would be there. What would K prime be? Same spot, right? All right. And then H, what you're going to do is you're going to find the perpendicular distance, right? And you can eyeball that. And then just do the same distance here, yeah? So that'll be where, what will you call that? H prime, yeah? And so there's our new shape, right? Can you see your new shape? Like this? Yeah? Pretty simple, right? All right. That is how you reflect over a line. You can do this with a compass, right? You would have to find the perpendicular bisector of some line, and then you would just reflect it over here and connect the dots, yeah? You could do it with a triangle, right? So you would come here, well, pick that point, right? And then you would do something like this with a compass. We're not going to do this on our homework, but you would just do a compass strike, right? Like that. Come here and go blunk, right? Measure that distance and do blunk and then just connect it, yeah? But we're not going to get into that in this lesson, okay? All right, so let's do the second one. A little bit harder, right? All right, so if P is here, then P prime will be at a perpendicular. Looking like about here, I'm guessing. Would that look reasonable for P prime? Maybe a little bit farther along, yeah? I don't care if you're not exact, yeah? I'm not going to count off for that. All right, so that's where that one would be. Now, M would be at a perpendicular, right? So it's that distance perpendicularly. So you would come here, and it's about here, I think. Maybe a little bit longer, maybe here. M prime. And N's there, perpendicular. So your perpendicular would be here. That's going to be about here, it looks like, right? That's N prime. And then just sketch it out and see if it looks reasonably like the picture, yeah? So L is going to stay there, right? L prime is going to be at the same spot. So there, and then what? Here, here, and is there one more? Yeah, here, right? I'm thinking it's like this, yeah? I might change my color. Like this. That look reasonable? Why do I feel like that's off? No, I guess it's okay. All right, something like that. If you want to be exact, then you get out a compass and you get really careful. Another thing you can do, you're not going to see this on the screen if you're watching this video, but another thing you can do that can help you to find it is you literally get a piece of paper, yeah, and you lay the piece of paper on the screen so that it's perpendicular, see? And you know that distance will then just come here, see? And put a dot there, yeah? Then it's, as long as this is perpendicular, you're good, right? So that's another way to do it. All right. All right, so that's how you reflect, right? All right. Pretty easy. Now we're going to have to get to the more interesting stuff. Reflecting over lines. So let me just talk for a few minutes first. All right. So if I have, let's say I'm reflecting over the x-axis, right? And I have this point, I don't know, whatever, 1, 2. And I'm going to reflect it, right? Where would it go? Yeah, it would go here, right? Which is negative 1, 2. So what happens? So that if we call this xy, what happens? Negative xy. So when you reflect over the x-axis, oh, no, that's not true. No, no, no. What is that? It's like that is not going to work. 1, negative 2, yes? So what is that point? Negative y. So be careful. When you reflect over the x-axis, xy becomes x negative y, which is the opposite of what you think. You would think reflecting over the x-axis would change the x, but it changes the y, yeah? And then vice versa, right? If I reflected over the y-axis, right? That 0.12 would go where? Here, and that would be negative 1, 2. So when I reflect over the y-axis, what would happen? Xy becomes negative xy. Pretty simple. All right. The not so simple one, and we actually see these on the high school number sense test sometimes. If you reflect something over the linear parent function, so y equals x. All right. So I just pick a point, and I'm going to get it a little bit off. So like here, that's what? 1, 4, right? Okay. Now where's it going to reflect to? Remember how it reflects? It reflects at a perpendicular, right? So it's going to look like somewhere around here. And then you have to eyeball that. What would that be? 4. That's looking like 4, 1. Yeah? So when you reflect over the y equals x, what's going to happen? xy becomes yx. Easy? What else could we reflect over? Negative parent function. So if you reflect it over this line, right? Yeah? We got 4, 1, right? And it would reflect like this, right? First of all, I got to make sure I'm got something that's looking like the negative parent function. Yeah? Where does that look like it's going? Probably like around here. Yeah? Somewhere around there? Looking like what could it be with these numbers? 1, negative 4. Yeah? So reflecting over y equals negative x, xy becomes, let's see, we flip-flop them, so it's yx, right? Which one gets negatized? Well, I know it just, the second part, yes? Which would be the x, but they got flipped, so it's the new y, yeah? Okay. If you ever forget those, what do? Make a quick little sketch of something, and make sure the point you pick is like not easy to, like stretched out, like maybe 1 this way, but 5 that way or something, yeah? So that when you reflect it, you're getting a point that's off a little, yeah? All right. And that's all this is saying here, yes? And we probably want to include this, right? Let's do this one. And when I'm reflecting over y equals negative x, what did we say? I'd rather do this, right? xy becomes what for this one? I think it's better to do it this way. When we reflect over the x negative y, right? On this one, xy becomes negative xy. When we reflect, xy becomes yx. And when I reflect over that, xy becomes, we flip-flop them, and we negatize, what did we say? The x, the second part, yeah? Negative x. All right. All right, so we graph FGH, right? It's already graphed for us. And we're going to do 2 things. We're going to reflect it over x equals negative 1. Now, where is x equals negative 1? That's this line right here, yes? Yeah? So it's real easy to reflect this because if I'm reflecting over this, it was to this direction, so it's to this direction. What do we call this point? F prime, yeah? And H was there, so the new H would be here. That's H prime, yeah? So can I see my new shape? Yeah, it's right here. And then what else are we doing? We're going to reflect it over the parent function, right? Right? All right, so the parent function, I'm going to graph it first. The parent function is going to look like this, right? That's the parent function. So H, it looks like H stays, right? So H is there, right? Where's F going to be? So we got to know where F was, right? Where was F? It was at what? -2. Is that -2 or -3? -3 what? 1, 2, 3, 4, 5. So F was at -2, 5 or -3, 5? -3, 5, right? So F was at -3, 5. So where would, actually, I'm going to do this here. F was at -3, 5. So when I reflect over the parent function, what happens? F prime is going to be at, I'm actually going to call this F double prime because it's going to be a new point, which becomes what? We flip-flop them, 5, -3. Oh, so 5, -3. 1, 2, 3, 4, 5, 1, 2, 3. I think that's 5, -3. Let me make sure. 1, 2, 3. Yeah, 5, -3. That is where F double prime is, yeah? H is going to stay. And we need to know where G was. G was where? -1, 4. Okay, so it becomes G double prime. Becomes 4, -1. So let's do that. 1, 2, 3, 4, -1. That is G double prime, right? So there's my new graph. Can you guys see it? It's looking like this. All right, easy? All right, for this next section, we're going to do some reflections and stuff, but we're not going to do all 3 points. We're always just going to do the first 2. All right? All right, so let's graph this. D is at -2, -1, -2, -1. That's D. E is at -1, 3, 1, 2, 3. That's E. All right. What am I reflecting over? I'm reflecting over this line, yeah? So where's D prime going to be? It was 1 below, so it's 1 above. That's D prime, yeah? So that was my original line right here. Can you guys see it? That's my original line. Oops. That's my original line. Sorry, this thing will not draw straight lines on here. And where's E going to be? It was 3 up, so it's 3 down. So there is my E prime, and there's my new line, yeah? All right, let's just do the first 2 points. So 1, 4 is here. That's A. And 3, 2, 1, 2, 3, 2 is B. That's my original line. What am I reflecting over? The y-axis. So that one, yeah? So each point gets moved. It was 1 that way, so it's 1 that way. We'll call this A prime. It was 3 that way, so it's 3 this way. 1, 2, 3. So that's B prime. So there's my new line, yeah? Hard? No. All right. This one's going to be a little bit harder to do, all right? If you're good at art, this chapter, if you're good at art, sometimes it's pretty easy to do because of art. All right, this is what I would recommend you do. Needs to be a 1. All right. What that's going to be is a translation vector. Yeah? So basically what you're going to do is take each point and move it along that vector. Yeah? So we're going to take that vector, this is the distance of the vector, and you're going to start from T and you're going to draw that vector, yeah? Maybe like about here, right? That's going to be the new t, right? Be about there. Can you see the translation vector I'm doing? Like this, you see it? Yeah. The next one will move along the same way. About here, I think. You can clean it up afterwards. If you want to get exact, you would not do it this way. You would grab a compass and do a whole bunch of constructions. Yeah. Can you see the translation vector I'm using? Yeah. I wish that thing was better. That one's not good at all. There, up here. All right, there's the translation vector, yeah? And V was there, bang, bang, about here, I think. That's V prime. Can you see the vector I'm using? And that one's going to have the same vector, so about here. And then you can clean it up if you need to. It's actually pretty good. Can you see what happened? So this is my new shape. This thing doesn't let you draw a straight line. It purposely makes it curved. What a dumb idea. Yeah, that is not what. So look at that. What's wrong with it? Think that this this probably needs to be more like this, right?
Yeah, it's a little short.
And what?
The V is too far right.
Yeah, the T should the B should moved over a little bit. Yeah, so the V should be here-ish, right? Probably, right? That closer. And you can play with it a little bit, right? If you have a piece of paper, it's actually, that is not looking good at all. You know what? I am hating this. Bonk. Up here. Up here. Up here. Why is that one giving me fits? It really is. Not here. I feel like that one's off. Yeah, it's a little bit farther. All right. I'm thinking like this, yeah? Just clean it up if you can. That's looking better, right? That one probably needs to be a little bit. No, it's not too bad. Maybe like this. There it is, yeah? Something like that. It doesn't have to be exact, and you can see your translation vector, yeah? Yeah? And it'll make that three-dimensional box. Yeah? In fact, I mean, that's literally how you do it. If you take a box and you just create the translation vector and you connect it, you're just going to make that again, right? People who are good at 3D figures, right? You can start seeing it, yeah? That's what you're doing. All right. All right, so the second one. That's my translation vector. So each line is going to be like this, yeah? Something like that. And then just figure out how far. About here. About here. All right, so it's looking like this. Gosh, that was so much easier than the last one. All right, that makes sense? Is that hard? All right, we're not going to do all three. We're just going to do the first two. So we're just going to do these two. Now don't erase that part. Now look, these are points, yes? That's a point and that's a point. What is this over here? It's a translation vector. Yeah? So let's describe this. So that translation vector is saying xy becomes what? What would the translation vector of 4, 5 do? X plus 4, y plus 5. Yeah? All right. And I would actually not, I mean, you can graph your original. What are we at? -3, 4, 6, 8. That's t. And negative 6, 3, 2, 4, 6. Be careful, you're going by 2's there, not 1's. And then what? 3, 1, 3. That's u.
T should be on the bottom. It's negative.
2, 4, 6, negative 6, 3. Oh, t is wrong. Good catch. Thank you. What is that? Negative 3 I did, but I went up 8 instead of 2, 4, 6, 8. There is where t is. Yeah? All right, so there's my original line. And then what am I doing? So if I had the point negative 3, negative 8, I would actually do this here. What would happen to these points? Negative 3 goes to where? Not if you do math. 1. 1. Negative 3 becomes 1. Do you understand how I got that? I took the x and I added 4 to it. Yeah? Negative 8, what? Negative 3. The way that happened is I added 5 to it. Let's try it again. Negative 6 becomes negative 2. And 3 becomes 8. So there's my new points. 1, negative 3. 1, negative 3. 2, 3. That's here. I'm actually going to change my pin for this. That's here. And what are we going to call that? What is that point called?
Yeah, that's it too.
What am I doing? What did I just say? 1, negative 3 is here, yes? Is that right?
Yeah.
All right, t, and what do we call that? It's not t.
T prime.
T prime. And negative 2, negative 2, 8, 2, 4, 6, 8, that is going to be u prime. And there's my new line. And you can you see the translation vector? It's like this, yeah? And if you looked at it, it's going over 4 and up 5, right? Okay. All right, let's try it again. Let's just do the first 2 points. All right, graph those 2. So 2, 5, 2, 4, 5, that is Q. 7, 2, 4, 6, 7, 1, that is R. All right. So I got 0.25 and I've got 0.71. All right. What is this saying? This is basically saying XY becomes X minus 1, Y minus 2. So this point 2, 1 becomes this point 2, 5 becomes 1, 3. And 7, 1 becomes 6, negative 1, right? Change my pen color. So I get 6, negative 1. So 2, 4, 6, negative 1 is here. I call that what? That's Q prime. And R is at 6, 1. 2, 4, 6.
That's up to you.
What did I do? Did I just do R?
That's R.
No, I just did R. 2, 5 becomes 1, 3, 2, 3. All right, there we go. That is Q, right? So there's my new line. And can you see the translation vector? It's like this, right? Hard? No, slightly tedious, but that's really there is to this, right? I'm not going to give you a ton to do on these, but really just being able to get a feel for them. If you want to be exact, you can get into the algebra behind it, but that's not what we're doing here, yeah? All right.